Alright, so this is number 9. The radius of Mercury is given there in kilometers, and the acceleration of gravity at its surface. Now, acceleration of gravity is another way to say the gravitational field strength. So that's just another expression for it. And then, so they want to know, they give that value. Excuse me for a second. All right, so they give us the gravitational field strength at the surface, and they want to know the mass of Mercury. All right, so we're here, we're in a written Y. This is a gravity problem, and it's number 9. So let's see. I'm going to start off the gravitational. Spelled that wrong. Field strength is due to the mass of the planet. Actually, I might put a sentence before that. How about my planet is Mercury. Mercury has a gravitational field. How many times are we going to spell gravitational? Correct. Not this time. Gravitational field since it has mass. The mass of the planet and how far you are from the center of the planet. Let's see. Oops. Gyrational. Yeah. Good. Is it Monday, really? Maybe they only make it oops. Probably should put notice in there that when at the surface of the planet, I am a single radius away from the center. Yeah. I think that's everything. Let's see. Okay. Yeah, I think that would hit all my Y points. Let's see. Do I clearly understand the physics in the problem? Yes. I understand a gravitational field created by mass. Clearly it's a problem. Yep. I mentioned Mercury. I mentioned where I am on it. Explain why the universe works this way. Yes, because gravitational field is created by mass. I didn't say I'm going to use this equation or anything like that. I didn't tell how to solve it, just the why, the ideas behind it. Good on the Y for number 9? How many people had any of those points, a couple of those points in your Y? Only a couple people? Okay, good, good. All right, let's move on to the how. And the how is my mathematical solution. So I need to write it. Now you guys realize one of the reasons I do all these on the board is as a model for how you should do the problems. All right? I think some of you may have disconnected on that on the last problems that I was looking at. So let's see. I need my equation sheet. So gravitational field strength is little g. So my expression for little g is this one right here. Grab that. Hiccups are always funny. There's my gravitational field strength equation. Let's see. Little g is my gravitational field strength. big G is my universal gravitational constant. I should probably grab that value too. That's here nicely convenient on the back side of my equation sheet. Let me grab that. Good. So I have that mass of the planet, or in this case Mercury, and then how far I am from the center of the planet. Remember that R doesn't stand necessarily for radius, it stands for how far you are from the center. Or like in Newton's gravitational equation, how far the centers are from each other. So in my case, it's I'm gonna have to look at my problem and find my values. All right. The other thing to note is look at the units there of my of the universal gravitational constant. It's in newtons and meters and kilograms. So that means I want a gravitational field strength in newtons and kilograms. I want a mass in kilograms, and I want my distance, my R here, in meters. All right, so I need to make sure I keep my units in agreement. That's why there's points for substituting in with units. So let's see what I know, what I need. Bless you. Radius here, I know I'm one radius away. That's 2,400 kilometers, which is, add 3 more zeros on there, so 2,400,000 meters, right? 1,000 kilometers in a meter, or 1,000 meters in a kilometer, excuse me. And then they tell me 3.7 in meters per second squared, which is the same as newtons per kilogram. So let's go back here. So substituting in, I have 3.7 newtons per kilogram, or if you write meters per second squared, same thing, over 6.67 times 10, excuse my bad writing. M is what I'm looking for, and I'm just going to put a little subscript M on it for Mercury. And then they told me how far away I am. That's 2,400 kilometers, or 2,400,000 meters squared. Yay! All numbers, one variable. Can I solve it? Okay, I can solve it. Can you solve it? Yes? No? Excellent. All right, so on to number 10 here. We've got 2 bowling balls at rest on a rack. And what's the force of gravity of pulling each ball towards the other? So, let's see. This is number 10. Oops, I want this. Thank you. Number 10. I'm going to change each of the balls have mass, thus they are attracted to each other. Due to a gravitational force between them. The more mass they have, the more force. The further they are apart, the less force. How far apart they are, should be measured center to center. I think that works. I think that hits all of my rubric points. Did I forget anything? Who's doing, just so my curiosity, who's doing number 11 with me? Anybody? 10. 10, sorry. 10. Okay. Well, at least one of you, I'm willing to do it. Excellent. All right. Let's move down to our how then. For our how, I need back to my equation sheet. I need the force of gravity between them. I can grab my gravitational force, universal gravitational force equation right there. Set in. Here we go. Nice. I need my big G again. It's taking place in this universe. Go. Alright, so again, I'm hoping that I have masses in kilograms and the distance between their centers, which we use the variable r for, in meters, because then my life is simpler. So, and I'm looking for the force of gravity, so I'm looking for F sub G. So, F sub G equals big G times, let's see, mass of one of the objects. Does it matter which object is object 1 and which one's object 2? No. Because we know it's equal and opposite forces. So 6.2 and 7.9. And then over the distance between their centers, which for me is 0.78 meters. Quantity squared, kilograms, meters. So I'm going to end up with an answer, of course, in newtons. So I should do the math, just make sure. Now, one of the, I'll tell you, a stumbling block for a lot of students on these type problems is they don't know how to use a calculator. They don't know how to use the exponent feature of it. So if you don't know how to use the exponent to put in like the number like 6.67 times 10 to the negative 11, either grab someone who does or grab me, since I'm someone who does, and learn how to do it. It will save you a lot of hassle. Seems right. So I got 5.37 times 10 to the negative 9. So when I put that in, of course, I'm going to put in 5.37, and then I'm going to use their pre-made formats to make sure I put in the negative 9 correctly. Alright, let me know if you have a question on that one, or... Alright, so, we're doing whatever, what is this, 5? And they're asking about the center of mass of the Earth-Moon system, and then once you've done that, then they ask about the Earth-Sun system. So I'm going to actually mine's going to be diagrams, and it's going to actually be 2 diagrams. All right, so number 5. I want to do diagrams. Okay, I better put that on the board here. Alright, so I need the moon and the earth, and then in the second part I also need, that's not big enough color difference. In the second part I'm also, in part C, I'm also going to need the sun. Alright, so I'm just laying those out. See if I can draw a line between them. Yep. And so, for the first part, my reference point, so I'm going to put here and call that reference point number 1. Because when I do that first part, they want me to reference it there. And actually, I'm going to call that our reference point part C. Whoa. What happened there? Something crazy is going on right now. What N? M for moon. Right now I'm trying to figure out why I'm getting craziness. Save on that real quick. Alright, hopefully we solved that little fun. So we're using the center of the sun for a reference point in that part, and in part A, we're using the center of the earth as our reference point, right? And they give us, this would be radius Earth, moon, and this is radius Earth, sun. I suppose I should do a capital R there. Alright, so that would be my diagram for this. So, part A. We're going to use center of mass equation. In part A, where we just have the Earth and the Moon, how many objects do we have in our situation? 2. Exactly. So in part A, I'm only going to use this with 2 equations. So if I'm looking for X, I'm looking for the center of mass. I'm going to have object 1, which is the moon, and then radius from Earth to Moon, plus mass of the Earth, radius from the Earth to the Earth, because the Earth is my reference point, mass of the Moon, plus mass of the Earth. Because I'm referencing, my reference point here is from the Earth, is the center of the Earth. That's what they asked me to use. Alright? So they tell me the mass of the Moon. Guys, remember you don't have to pay attention, but can you keep it down a little bit? Because you're distracting me. They tell me the mass of the Moon. They tell me the mass of the Earth. They tell me the distance from the Earth to the Moon. Alright, so those are all these values I can plug in there. I'm trying to go a little quick. Do you want me to actually plug those in? Okay, you can do that. So, mass of the Moon, 7.35 times 10 to the 22nd. So, we're going to just go over the XCM. 7.35 times 10 to the 22nd. Radius Earth to Moon. Moon and Earth 3.8 times 10 to the 5th kilometers. Plus mass of the Earth, 6 times 10 to the 24th. And then how far is the center of the Earth from the center of the Earth? 0. Didn't even need to look that one up. Over 7.35 times 10 to the 22nd kilograms plus 6.0 times 10 to the 24th. Yay, all numbers on one side, one variable on the other, and that's the variable I want. So yay. And then when you do the second part of this, you have not only the Moon in there, but also the Sun. So you take it from the Sun center. You're going to have 3 objects, the Moon, the Earth, and the Sun. And all of the X's, all the lengths here, need to be measured from the center of the Sun. So, in that part C. So you've got how far, where's the Earth? Well, the Earth is the radius of the Earth to the Sun. Where's the Moon? Well, it's the radius of the Earth to the Sun plus the radius of the Earth to the Moon. Alright, so we've got to combine those. Alright, I'm going to pause.